In this discussion, we are going to discuss about F block element. If the differentiating electron enters into F subshell, if the differentiating electron enters into F subshell, those elements will be called as F block element. We already know which electrons are called differentiating electron. Last electron is otherwise known as differentiating electron. If that last electron enters into F subshell, then the element will be present in F block. In periodic table, if you remember the periodic table, S block will be extreme left S block, middle D block, extreme right is P block. This F block will be present bottom of the periodic table separately. Actually, this is not the correct form of periodic table. Correct form is first you have two groups in S block, then D, one group in D block, then you have F block element, then remaining nine groups of D block, then P block. This is the exact form. As this is occupying the extra space in between S and D block, scientists just remove this part, just cut down this part, and they place it bottom of the periodic table. Then only this D will combine with this D. That is the main thing. That is the main aim. Why we are placing a F block element in bottom of the periodic table. Actually, this is a full form periodic table. Longest form of periodic table. This is the one. To combine this D with this D, only one group of D block. Here 9 groups of D block. D block contains 10 groups. No. To combine the one first group of D block with the remaining groups, we are cutting down this and we are placing in the bottom of the periodic table. That is the reason. And D block elements are known as transition element. We already discussed everything about that. Now see, these elements are present, this D block and this D series, this D series. This block elements present in between two D block. This is also transition element, this is also transition element. So these elements are present inside the transition element, that's why they are called as inner transition element. Why F block as the name inner transition element is, these elements are present these elements are present inside the transition elements. That is the reason F block element otherwise known as inner transition element. F block elements otherwise known as inner transition element. We already know D block is otherwise known as transition elements. For that also we already discussed the reason why it is called as transition element. Or rare earth element. Rare earth elements. And in F block we have two series. One is 4F series. 4F series starts with cerium to lutetium. 5F series starts with thorium to lawrencium. Now you might get the doubt, sir, 4F series otherwise known as lanthanides. So usually it should start from lanthanum, no. But actually speaking, lanthanum is not a F block element, lanthanum is a D block element. These 14 elements are present, they are following after the lanthanum. In periodic table, lanthanum atomic number is 57, cerium atomic number is 58, lutetium atomic number is 71. These 14 elements, 58 to 71, there are 14 elements. These 14 elements are following the lanthanum. That's why they are called as lanthanides. So the 14 elements after the lanthanum are called lanthanides. The 14 elements after the actinium are called actinides. See, you can write NOIDS or NIDES, both are same. NOIDS or NIDS, both are same. Thorium atomic number 90, lawrencium atomic number 103. They are present after the actinium atomic number 89. So this 14 elements comes after the actinium, that's why they are called as actinides. La symbol of lanthanum, AC symbol of actinium. This La is particular element, it's not a group of elements. Ln indicates 14 elements. This 14 elements can easily represented by Ln. This Ln indicates group of elements, lanthanides. AN represent actinides. It's a group of element. LN is lanthanide, it's not a single element. AN is not a single element, but LE and AC are single elements. 14 elements after lanthanum. 14 elements after lanthanum are called lanthanides. Only that is the reason. While arranging the elements in periodic table, this 14 elements show similarity in property. When we cross the lanthanum, we are able to observe this similarity. So we are saying the elements present after the lanthanum show similarity. That's why they are called as lanthanides. 14 elements present after actinium are called actinides. Clear? Which elements are called lanthanides, which elements are called actinides, and it's very mandatory. You should memorize this atomic numbers 58 to 71 and here 90 to 103. If you know the whole periodic table, it is easy for you. Otherwise, you should memorize this value in the atomic numbers. And F block elements also very important. We have a shortcut. I don't know how it will work out with you. Okay. Next, this 14 elements in each series. This 14 elements in each series. In 4F there are 14 elements. In 5F there are 14 elements. This 14 elements shows similar in property. F block elements shows similar in property within the 14 elements in each series. Lanthanides show similarity in property from cerium to lutetium. Actinides show similarity in property from thorium to lawrencium. They are similar in property within that 14. But F block elements shows different in property. They are different in property with D block element. They are not behave like a D block element. They shows different in property. The what variation or what similarity we are observing in D block, that is not applicable for F block. What property you are observing for F block, that is not applicable for D block. That is, they are different. But within that F block element, they are similar. That cerium to lutetium, they are similar. But cerium is not same as lanthanum. As lanthanum is a D block element. Next, electronic configuration. How the electrons are getting arranged in an atom, that is known as electronic configuration. First, we will complete the general electronic configuration. General configuration is n minus 2 f sub shell, n minus 1 d, ns. For 4f series, n value is 6. For 5f, n value is 7. For 4f series, n value is 6. N value 6 means 6s. We have to substitute 6 in the place of n. So 6s. N minus 1. So 6 minus 1, 5d. N minus 2. 6 minus 2, 4f. So n minus 2, n minus 1, n. General electronic configuration is 1 to 14. Here 0, 1 or 2. Here 2. This is general electronic configuration for whole F block. For 4F, then configuration is up xenon 54. Up to xenon 54 electrons are arranged. There is no doubt in that. 54 electrons are arranged. And general configuration is 1 to 14, 0 or 1, 2. For 5F, radon 86, 1 to 14, 0, 1 or 2, 7s2. Try to remember this, very important. Don't put 1 to 0, 1 to 10, that thing. D can accommodate 1 to 10. D can accommodate maximum of 10 electron. But in F block, in 4F, that 5D can accommodate either 0 or 1. For 5F, D can accommodate maximum up to 2. Now, for each and every element we need to remember. So these are all lanthanides. Lanthanum is not a F block element. Try to remember, lanthanum is not a F block element. Lanthanum atomic number is 57. So cerium will be 58. Praseodymium 59. Neodymium 60. Promethium 61. Samarium 62. Europium 63. Gadolinium 64. Terbium 65. Dysprosium 66. Olmium 67. Erbium 68. Thulium 69. Ytterbium 70. lutetium 71. What we have discussed here, lutetium 71. You will get lutetium 71. You just remember, see, elements is very very important. Order is very very important. In class we will discuss the shortcut. So cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, olmium, erbium, thulium, ytterbium, lutetium. For all the things, xenon 4f 5d 6s. For all the element that will come. With closing your eyes, you can write xenon 4f 5d 6s for all the thing. Once you complete this, see, up to xenon we used 54 electrons. Lanthanum contains 57. Up to xenon we used 54. So remaining 3 electrons. That 3 first 2 electrons will be filled in 6s. Remaining how many electrons? That 1 electron will go to 5d. See, there is no electron in 4f of lanthanum. That is the reason lanthanum is not a F block element. Lanthanum is pure D block element. Now come to cerium. 58, 59, right? Okay. So up to xenon 54 used. In cerium we have 58 electrons. Up to xenon we used 54. Remaining 4 electrons. Now we need to arrange the electrons. How we should distribute the electron. That is very important. To understand that, see, there is no exception in 6s. All the 6s will get 2 electron. 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. All the 6s. But, so 54 electron, here 2 electron. So total 56 electrons are used. Remaining how many electrons? Cerium contains 58. 56 we used. Remaining 2 electrons. For first element of lanthanum, 7th element of lanthanum, 14th element of lanthanum. F can accommodate maximum of 14 electrons. Half of that 7. First one is 1. So first element, 7th element, 14th element. Try to remember this way. F can accommodate maximum of 14. Half of that is 7. And first one always, as it is a starting point, we should include that one also. So first element first element cerium, 7th element gadolinium, last element lutetium, 14th element. Only these 3 elements has 1 electron in D. 1, 1, 1. Now see, cerium contains 58, which indicates only this 3 element has electron in D subshell. Other elements are all 0. There is no electron in D subshell of other elements. Now cerium contains 58 electrons. Up to xenon we used 54. Here we used 2, so 56 and 1, 57. Remaining 1 electron, that will go to 4f. Now praseodymium 59 electrons. Up to xenon 54 were used. Here 2, 54 plus 2, 56 were used. Remaining 3 electrons. That 3 will go to 4f. There is no electron in 5d. So here 60, 54 used. Here 2, 56 were used. Remaining 4 will go to 4f. Promethium 54, here 2, 56, remaining 5. Here 62, 54, 56, remaining 6. Europium 54, 56, remaining 7. Gadolinium 64, up to xenon 54, here 2, 56, here 1. How many electrons? 54, 56, 57. Remaining 64 electrons are there. Remaining 7 electrons. That will go to 4f. Terbium 65 up to xenon 54 to 56. 65 minus 56. 9 electrons. Here 10, 11, 12, 13. 70. 54 electrons. Here 2 electrons. 56, remaining 70 minus 56, 14. Here 71 atomic number. Xenon up to xenon 54, here 2, 56, 57, 71. 57 electrons used, remaining 14. Is it clear? So this is a way to fill the electrons for lanthanides. Now we'll move to actinides. This is very easy shortcut. At Pun pack BCE I used to remember like this. If you have any other shortcut better than this, please go with that. At Pun pack BCE actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, einsteinium, fermium, mendelevium, nobelium, lawrencium. I repeat, actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, einsteinium, fermium, mendelevium, nobelium, lawrencium. So up to radon, 86 electrons are used for F5F6D7S. Again same thing. There 4F5D6S. Here 5F6D7S. Only we need to add 1 with the shell numbers. So actinium atomic number 89, thorium 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103. Now how to fill the electrons? Everywhere 7 S subshell will get 2. Now what are the things are important? F can accommodate maximum of 14. Half of that 7. First one. These are very important, no? Along with that, one more thing is important. This F1 is separate. First one is separate. First element of IF series contains 2 electron in D subshell. See, this is very very important. At the time of exam, we used to forget this thing. First element of IF series contains 2 electron in 5D, and immediate after 3 elements having 1 electron in 6D, having 2 electron in 6D, then immediate 3 elements will have 1 electron in 6D. Then automatically 7th element, yes, 7th element, americium, sorry, I made a mistake here. This one is curium, Cm, curium. So 7th element is curium, right? 1, 2, 3, 4, 5, 6, 7. Don't start with actinium. Thorium is a first element of actinides. So this is the 7th element, and 7th element will have 1 electron in 6D, and last element will have 1 electron in 6D. Only thing, first element have 2 electron, then immediate 3 elements have 1 electron, then 7 and 14, that is common. Other D subshells are empty. As usual, other D subshells are empty. Now arrange the electrons. Up to radon 86 were used, and here 89, 86 were used. Remaining 3 electrons, 2 here, 1 will go to 6D. Here 90, up to radon 86, 88, 90. So there is no electron in 5F of thorium. This is the electron special configuration, try to remember. protactinium 91 electronic configuration, 86 valence electron up to radon 86, 88, 89. So remaining 2 electrons. 92, 86, 88, 86, 88, 86, 88, 89, no, sorry, 91, okay, 92, 86, 88, 89, remaining 3, here 4, 94, 86 electrons are used, here 2, so total 88, remaining 6, here 7, 95, 86, here 2, 88, remaining 7 electrons will go to 5, 86 radon, 288, 89, remaining 7, 97, 86, 88, 97, remaining 97 minus 88, so 8, sorry, 97 minus 88, 9, 9, here 86, 88, 98 minus 88, 10, 11, 12, 13, 14, here 103, 86 plus 2, 88, 89, 103 minus 89, 14. So this is the electronic configuration for 5F series. Remaining things we will discuss later. Thank you.